So welcome to the Spryker talk. Very happy to see so many people. I'm very happy to see you all here because that's why I'm doing the talk in English, that you can listen to it. Let me introduce myself. My name is Fabian Wesner. I'm the CTO of Spryker, and yeah, you can. If you like to, you can follow me on Twitter. You can also Twitter while I'm talking. I would really happy to see some tweets afterwards. And if you like to, you can read my blog, my tech blog, and all these slides are available on SlideShare. So there's no reason to make, no need to make pictures of these slides. Maybe you heard of us already. We appear in every talk here. So maybe you have read this name. And the beginning, I would like to explain why we exist, basically. So why there is something like Spryker, why there is a need for e-commerce framework. Well, basically, that's the reason here. As you can see, there are tons of shop software in the world. There's a huge Magento, there's a Shopware, there's Oxid, and so on and so on and so on. And also, there are so many systems, there's so many platforms that you can choose from. Still, a lot of merchants decide to build their own stuff. So these three statistics here. I mean, they are not, no statistic is perfect, so they show a little bit different numbers, but you can see here, this can see that a high percentage of all our merchants run on a self-developed system. So same here, you can see here, 30%, same here, a lot of merchants develop their own stuff. So there's something missing in the market. So it seems like, it's not like they have too much money and time, that's probably not true. It seems like that existing solutions do not fit. Well, the answer is, first, what standard systems offer is, they offer a lot of features. So basically, that's a classical shop system approach. The system which offers the most features, that's the system that people will choose. And that's totally enough for most of all merchants. So for the small merchants which run a shop which make 1 million revenue, then a standard system is fine. But, well, the small sentence here is important. If your business model is not standardized, then a standardized system does not help you. So, I mean, you can see that even these systems, standard shop systems, provide a lot of features. You still see like 500 man-days of development that goes into a launch of a new Magento shop, still. So it just doesn't fit for the ambitious projects. And our approach is different. So instead of building a system that provides thousands of features, we say what these ambitious projects need is a framework that optimizes the productivity of the developers. So Spryker is much, much more of a tool for a developer's team. So how do we do this? I will very, very quickly go through all of these things. This is something which is probably not, which does not fit to managers. When a manager wants to know what Spryker offers, that is not the right slide. So this is something for developers. So why is Spryker a tool that increases the developer's productivity? Well, first of all, we are serious about clean code and solid architecture. So I have more slides to go a little bit deeper here. We have a consistent software design. That's very important. The whole software must have the same software design. So if you learn the software design, it will take you a week, maybe 2, but then you know basically everything. You can deep dive into every bundle, and every bundle looks the same. Very strict modularization, so it's very important. A little bit like web service, but without the drawbacks. And very, very important is a generic set of features. Instead of having thousands of features, we only need a small number, but that we need features that are very, very generic, like state machines I have on my last slide. High performance scalability, super important, not only for usability, it's also important for productivity, because if your developer invests time into things like, I don't know, full page cache or server scaling, this is just a waste of time. This is time that the developer does not build features, so it has no business value. So maybe it's fun for developers, but no business value for the merchant. Deterministic behavior. So I expect that the shop looks the same on every server. So I don't expect that the cache is outdated and so on. I don't expect that there's some race condition, that there's a slave flag, whatever can happen. So deterministic behavior is important. Tested and measured code is very important. And when we started with Spryker, the first thing is we looked at other systems and we said, okay, what did we identify as a bad practice? So what can we learn from other systems? And here I have a list. Our full page cache is something which is absolutely not good in a shop system, basically, because you want to show different content to different customers, and you just do not want to waste your time with cache invalidation and cold cache issues and so on. EAV, we talked about yesterday. Event dispatcher and aspect-oriented programming, that's something which is a lot of developers like, but it's killing productivity in large teams, because the system becomes spaghetti code at the end. If you have 1,000 events, then the system will behave somehow, but you do not know what happens because code is disconnected. Code configuration database or XML, YAML files, everything that steals the IDE, the possibility to read the code. Dependency container magic. So you probably know all of these words, and we could probably discuss about all of these words, but I think in big projects with large teams, that's something that kills productivity. Okay, that was the motivation. I hope you have a rough understanding why Spryker exists. Now I would like to show you the system. That's the so-called bird's eye view. That's the picture that we always show when we explain Spryker. I will quickly explain it. So Spryker consists of two applications called Eve and Set. So this is one of the observations that we did as other systems is like, it's really, there's a target conflict. You have a shop front end where customers come. This front end should be lightweight, easy to change, very and scalable, and so on. And you have a back end for administrators where you run your business logic, and you have maybe design patterns, you have really architecture, you have heavyweight architecture to solve these business needs. And you cannot build these two things into one application. That's a target conflict. And that's why we said, okay, our system consists of two applications. So Eve is a shop front end. That's what our customers will see. It's very fast, it's scalable, and it's very easy to program with it. And you have a second application called Set. This is where we have all the business logic, where we persist our data, and where we connect to external providers. And in between, there is something we call remote procedure call. It's not really true, but it's something. It's an internal web service, so I didn't find a good name for it. But basically, we're sending data from Eve to Set. As you can see, we also have a relational database. So this is where you have all the orders, customers, products, CMS content. It's a relational database. So we're here because we need consistency, integrity, and we definitely want to draw a schema. That's why it's an SQL database, so Postgres or MySQL. But that database usually becomes scalability bottleneck. That's why the front end has no direct connection to this database. That's why we have a key value storage here, a NoSQL database, Redis, and Elasticsearch here. That's for full text search and facet filtering. And there's a cron job that update these two storages whenever something changes here. So, like every minute, a product changed, we have it updated here or here. This is not a cache. This is more like our asynchronous database slave. And the data is not only copied over, it's prepared. Like, for example, here, you have a product, then you have another table with stocks, another table with images, another table with categories. And to show a product detail page in the shop, you need all this data merged into one array. And then exactly this array is here. So the expensive operation of doing the query, the join, this is asynchronous with a cron job. And then here we have the data prepared. And then Eve, all that Eve needs to do is to take the data from here, put it into the trick templates, and show it to the users. So that's why this application is fast, because there's no expensive operations. We're also using Redis for sessions, and our concept for Elasticsearch, by the way, this is something which is very, very close to what Martin Lötsch explained in the talk 2 hours ago. So that's one of the results. The application is fast. So as I said, I really, really want to avoid any kind of full page cache. I think full page cache is an anti-pattern. And instead of having a slow application and I need a full page cache to make it fast, varnish, whatever, we say, no, the software should be fast by design. So the idea is that Eve executes in 30 to 100 milliseconds. This obviously depends on the hosting environment. So this graph here with 27 milliseconds is from our optimized bare metal hosting. So this is what you get if you have a really big server and no virtualization. So if you put the same thing on Amazon, you probably go to 80 milliseconds. So it's slower, but you can scale easier. That's a trade-off. But it doesn't matter. It's more important that the application is fast by design, and then with hosting, you can adjust it as you want. Not the other way. You have a slow application, then you need tons of servers to scale it. So it's fast and scalable, well, because our Elasticsearch and Redis is very easy to scale. You can just add another node. It will fill up in seconds. And the relational database is protected, so it cannot reach directly from Eve. So the relational database is only used if you save an order or calculate a discount. So only these kind of operations which are very, very, have a high business value. So if your SQL database dies because you have so many orders per second, well, then probably you also have the money to buy a bigger server or better service. So this is the idea. Instead of scaling the SQL database, we protect the SQL database by design. We are very serious about code quality and coding principles. So Spryker, when we started to implement Spryker, we said we want to have very, very good code. So very good code is a lot of, could discuss a lot. And we said, well, we say very good code is code that follows the solid and packaging principles. If you would like to learn them, then either the blue or the green book are for you. And it implements clean code. So basically the principles come from Uncle Bob, probably most of you will know, and to do this properly takes a lot of effort. And the result is, I hope the result is good. You can see the code is public. You can just go to GitHub and have a look if you like to. We also measure the code with Scrutinizer, and we have a project boilerplate, which gets a 9.7, 10 would be the highest rate, and 9.55 for the core bundle. So we try to optimize it a bit, but we'll probably never go up to 10. That's quite good, I think. And yeah, please feel free to look into the code by yourself. Now I would like to talk about the software design more in detail. Well, that was the first sketch. We start, okay, we want to have two applications, front and back end application, Eve and set. By the way, this system is the successor of another system that we created for Rocket Internet. It's called Alice and Bob. So if you ever worked for Rocket Internet, you probably heard of Alice and Bob. So and then here we are. So I'm the architect of Alice and Bob and Eve and set, and we just needed another name, and we decided for the last letters of the alphabet here. So Eve and set. That was the first sketch, and then we started with our architectural thinking. So what we wanted to have is the best of two worlds. We wanted to have all the benefits from a single application. So we wanted to build something which is basically just a PHP application. So if everything is wrong, you can start your debugger, PHP storm, and just go into the application. And it should run on every laptop. That's very, very important for productivity. So every developer must have the whole thing. So very important. It's a detail, but it's very important, I think. And also deployment should be a no-brainer. So it shouldn't, the effort to build infrastructure and run the deployment should be as low as possible. Those are all the benefits that you get from a single application. But, as we all know, single applications, also called monolithic applications, have the problem that they become very, very bulky for big projects. And we also wanted to get the benefits from a service approach. We want to say, even with large teams and big projects, we want to have very, very high productivity. So in applications where everything is connected with each other, you will very quickly see the problem that teams or developers change the same class, and then they get merge conflicts and all these things. And this is a productivity killer. And we say we want to have or go into the service direction and say we want high productivity. And very important, every part of the system should be can be updated individually, replaced, or extended. That was our architectural thinking. And but we did not want to have a technology zoom. That's what you get if you do microservice. You have 5 programming language, maybe. We do not want this because it makes the recruiting teams very, very hard. And we would not want to have our overhead of distribution, no asynchronous communication. It's not acceptable if the user cannot add a discount in the checkout because the discount service is unavailable. So we do not have asynchronous communication. And we do not want to have multiple database. So one database with transactions, with consistency, with relations. So that's what we wanted. And so we started to draw this. Well, we have an application. It's a monolith. Well, not so good. And then we started to bring bundles into it. Every shop system has something like modules or something. So, and there's a big difference between a directory, which is called cart or checkout, and something which is really follows the packaging principles. So, and this is, if you look at Spryker code, you will say, okay, they just have directories, like any other system. But that's not true. There is a big difference. It's very important that your whole code base is divided into functional units. We call them bundles. You could also call them module or package. Doesn't matter. We call it bundle. It has nothing to do with Symfony bundles, by the way. And each bundle has a single responsibility. That's very important. It follows the packaging principles. Very well-defined relationships and very clear API. That's very important. So that's it looks like detail, but not a detail. That's basically the main architecture here. If you look into one of these bundles, you will see 4 layers. So we're not talking about MVC. We're not kidding. We're talking about a real layered application, 4 layers. Presentation, communication, business layer, and persistence layer. And I think in a good architecture, it's very important. When you create a new class, there's no discussion, there's no question where the class goes into. You know exactly which bundle, and you know exactly which layer. So this is something in Spryker we solved, and this took a lot of discussion. Well, that is how the result looks like. We have 2 applications. Each application is modular and has these layers. So Eve do not have a persistence layer because there is no ORM here, but that's a detail. As I said, each bundle has an API. That's really important. One thing that you might know, like when you have public methods everywhere, and you expose all the public methods from the core to the project code, then everything is an API. So when everything is an API, nothing is an API. You just do not know. You do not know if you're busy breaking or not busy breaking. You just do not know. And that's why we say, okay, we have a bundle. So this blue box here is a bundle. And what is inside of the bundle, that's unknown to the user. What you see from the outside is a facade. A facade is a design pattern from the Gang of 4 that acts as an internal API. So this is the card facade here. And from the outside, a card has only 2 methods, add and remove. You do not know all the details. You do not know, if you use just this facade, you do not know, does it store the card into the database, or how is it calculated, however. So behind this 2 methods, there are maybe 100 classes maybe we replace the implementation. As long as the contract is not changed, it's fine. So that's an internal API. So we could also expose this as public web services, that you can access them with HTTP, but that would slow down the application. So I'm not a big believer here. If you look a little bit into details here, you can see the facade obviously implements an interface. We're doing even interface aggregation here, and I will also show a little bit more here about the code. And this is how we connect bundles. So it's not only important to have a clear API, it's very, very important in good software design to be very, very explicit about how bundles are connected. So here you can see that the card bundle talks to the facade of the calculation bundle. You could also say these are two web services. They're talking to the WSDL file of the other, but it's one application, so it's an internal call. And the card is calling the calculation bundles facade. So calculation is doing calculation, and card is representing the card. And the code here is a little bit, the way of thinking is a little bit different here. It's not like Symfony, where you have one big dependency injection YAML XML file, where everything is connected to everything. It's like, in our scenarios, like every bundle describes exactly what it requires. So here you can see there's a class called dependency provider from the card bundle. And here it says, I need a calculation facade here, calculation facade. That's what it basically says. The card needs a calculation facade. The rest of the code here, the closure and the container, you can ignore. This is because of performance, lazy loading. This is an implementation detail. We didn't find a way to hide this, anyhow, it's just how you connect. So each bundle says, hey, I would like to have something which is a calculation facade. Of course, there's also interface behind, interface which has exactly the methods that are needed from the calculation facade. So interface aggregation, clear decoupling. But anyhow, that's a very explicit way. And it's different than usually. Usually you would connect bundles on the outside, and our bundles are connected from the inside. We are very, to summarize the modularization approach. In Spryker, we have 100 bundles around, 100 bundles. And the idea is to go, to continue here. Maybe we have 200, 300, 400 bundles. We will see. The idea is that each bundle has a single responsibility, is taking care for one functional unit, and they are loose coupled, they're coherent, have explicit dependencies. And the big benefit, the reason why we did this is the code keeps well structured, even big projects. The code will, if you're doing this in a project like we do it in the core, and obviously we hope that you do it, then the project will grow in a very, very good way. So you can have teams for several topics, and also they work in the same application. They will not block each other. They will not conflict with each other. And that's because of these very, very loose coupling here of the bundles. That's the benefit for the projects. And the benefit for us and the project is this here. It's the release process that we are doing. We call it atomic release process. So one of the major issues with our monolithic systems is when you release a new update, then not every customer, every project can take the update, because we know that most of our clients will extend a part of the system. So maybe somebody is using Spryker to build a shop to sell concert tickets. So concert ticket would be a very typical use case for Spryker. So it's a little bit like a shop. It has a checkout, it has a card, but it has very, 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 very special requirements. So if you try to do this with another system, you will very, very soon fight the framework. That's why Spryker would be a very good tool to build a concert ticket shop. So concert tickets, very special. You have very, very high traffic that you cannot cache because people want to buy something. So maybe 50,000 tickets in 10 minutes. You have a plan where you have the seats, like here. You have an after-sale marketplace. You have a UI for the artists, and so on. So it's very, very special. So if you build this project, you will probably take the checkout, the cart, the discount engine as it is. So you will not change it dramatically, but you may replace the complete product bundle. So you will hack one part of the system. I'm not talking that you go and change a core code. I hope nobody's doing this, but you maybe extend a class. This is already a hack. Or you go deep. If you are in Magento 2, there's something called aspect-oriented programming, interception. That's also a hack. So you take any public method and you hook into it. Maybe with the next release, this method is gone and your hook will die. So you're losing backward compatibility. So if you do it 1 or 2 times, no problem. If you do it 100 times, it will take you a year to update. And that's a very typical issue with software, that to adjust it to your needs, you need to extend it. While you're extending it, you're losing backward compatibility. And then when the next big update comes with great features, you cannot have it because you need to adjust all your changes. So our approach here is like this. We say the whole system consists of bundles, as I told you, these modules. And there's no way to get Spryker without this, by the way. We have one repository which has everything, but this one is protected. It's only for us, for development, for core development. So if you take Spryker, you will get a composer file with around 100 bundles. And each bundle has its own composer file and declares its own dependencies. So, and that means, let's say, for the concert ticket merchant, maybe you want to take the new discount bundle here, version 3.0.0. But he does not want to take the product bundle because he heavily adjusted it to his needs. So you can just take the single bundle and update composer.json. The bundle requires some other bundles, so you probably also need to adjust some other bundles. And then he's fine with it. There's no, as long as we take care for decoupling of bundles, he can do isolated updates. And that's a win-win for us and for the customer. So the customer is good because he can take updates even if he hacked the system. And for us, it's a very, very big benefit because we are, as I told you, we are serious about software quality. And if you have to keep your system, if you have to avoid BC breaks all the time because there's no bundle split, then that means that your code will be full of workarounds. So to make a BC break for shop software is really, really easy. If you change one public method that you expose as an API, it's a BC break. So you have Magento 3.0. Of course, this is not going to happen. That's why you will see in old systems, which did not do big BC break since 5 or 10 years, you will see a lot of workarounds. So the code quality decreases over time. And this is not something, and you cannot do things. You know, we learned that we could build a much better discount engine. We have all the knowledge, all the experience, but we cannot do it because it will break all our customers. So, and this is, for us, it gives us the opportunity to just say, okay, we can make BC breaks. We can offer new bundles. And for the customers, for existing customers, it doesn't matter. So if somebody extended the product bundle and we deliver a completely new product bundle, it doesn't matter. If he's happy with the old one, he can keep the old one. He can also decide to go to the new one and then make the migration effort, but only for this bundle. So he does not need to make the migration effort for something he's not really interested in. So I think that's a major benefit here, and it took us a lot of time to build it. So you cannot just put Composer. So I've heard from other systems now, hey, we're using Composer now, but that is, no. Composer is a technology. What you need to do is you have to be serious about your modules, APIs, relationships, and then you can apply the release process here. And this also takes a lot of tooling. Like we have a torrent proxy that speeds up the Composer instance update. So if you have 100 bundles, Composer update would take 1 hour if you take it from GitHub. And with us, it takes 30 seconds because we pre-calculate the things. By the way, technically, we are talking here about so-called subtree splits, so if you're interested in this. So it's a topic which is really not so simple. I would not recommend to do this for small projects. I only recommend it for huge projects. But for our clients, it's there. It works out of the box. You can, if you like to, if you install our virtual machine, you can see all this in the next 20, 30 minutes on your laptop. So what we can do is, so our release process is also affected here. It's not like we make a new release every 3 months. It's like we can make a release of a bundle or feature every day if you like to. So we can have a continuous stream of updates to our clients. So yeah. Okay, now I would like to show you some programming with Spryker. Let's look into the code. Well, that's how we do a dependency injection. I'm not a big fan of programming with strings, so I like my code explicit. I would like that my IDE can pass the code without any plugin. And I do not want to have some background magic. Hey, you have to configure an XML or YAML, and then it's automatically injected, or auto detection of dependencies. This is really cool if you build a small application with Laravel. That's fine, no problem. But if you build a big system, you want to be very explicit. Maybe it takes 5 seconds longer to make explicit dependencies, but then you have it. All the other developers can read it, and it's very clear. So this is basically, we have a factory. The factory is in every bundle. That's a glossary bundle. And then in every layer. So we have 100 bundles. Each bundle has 3 layers with PHP code, so we have 300 factories. And each factory is only building its own classes and injecting only the classes from the same layer and bundle. So, and this is our, and you can very easily find them because it's very, very consistent naming principles here. So here we say we make a new translation manager. We use new here. That's probably something you do not see so often today. And then here we just inject these 5 dependencies here. Obviously, you will not find anything like this without interface. So everywhere is interface. Also, the constructor here inside is obviously only takes interfaces. So it's completely coupling on bundle to bundle and also on class to class. So this is something, there's no excuse to not do it, even in project. So we give you, so the Spryker, you get a set of best practices and features, but you also get architecture guideline. So we have an architecture sniffer also for our customers that then when they build code, we help them, we support them to make the code, the resulting code, really, really good. Because if they fuck it up, well then the benefits of Spryker will go away. So we also expect that if you create classes, make dependency injection, use interface in the constructor, do not have state in a class that have that shouldn't have state, and so on. So all these best practices, like we provide in a way that the project extension, the project code will grow in a very good way. So and we see really good results in our client projects, and a lot of developers who come from our other systems are really like the first time they really see something like solid, clean code in action. So before they just heard about it, yes, solid, what does it mean? I'm quite sure probably more than half of you does not really know what solid means, but it's fine. It will take you 2 hours to learn it, theoretically, but to practice this will take you 2 weeks. But it makes you much, much better developer. We also have plugins. So plugin is how we allow our extensions without our BC breaks. So like here, this is a calculation bundle. And to calculate, this is used by card. And if you calculate a card, you have calculators. So you have item gross price or whatever calculator, product option, grand total, blah, 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 and so on. And you have a lot of these calculators. And we say, okay, we provide these this method here, which lists all of the plugins. And then if you say, in my project, I want to have a different calculator, I want to switch out a calculator, I have a different text calculation, whatever, you just build your plugin and place it here. So you can hook in. And you can do this very, very safely because we guarantee stability here in this code. So with Spryker, the API is very, very explicit. We have facade, like internal APIs, and we have the plugins. We have some other things, but we know there is a case where you need to go behind this. You have to beyond this. You have to go behind the API. You take responsibility for a bundle into your project, which means you probably not get updates anymore, or will take a lot of effort. And if you do so, then inheritance is possible, but we do not recommend. So extend another class is not a good idea. So what we always say, you should do composition. So this is how project, if they need to extend a class, which is behind an API, they should do it this way. So they put their own model, and then basically it's composition. So it's probably not a big deal here. They get the core class into the constructor, they have a dependency, and then they delegate the calls. So basically you hijack all public methods. And the system has a way to switch out the core class with your own class everywhere in the system. So you hijack the public methods. So there's a little bit more effort to do than just inheritance, but it's much more robust. So, because if you inherit a class, maybe you override a protected method, and maybe with the next minor release, the protected method is gone, and that is fine, that wouldn't be a BC break, then your code will break. And here you can very safely repair the thing without having a big impact to your code. We also use a lot of transfer objects. So DTOs, data transfer objects, we have them everywhere. I think it's a bad practice to use arrays for data. Like, hey, I have my order array, and you have something inside, who knows what? We say we're using these DTOs. This is a customer transfer here. The transfer object is defined in XML. This is one of the very small cases where we have XML, but we use this to generate, basically you generate this class here, customer transfer. The reason why it's XML is because we are allowing to merge as XML, which is not so easy with PHP classes. And then you have a customer transfer, you can use this setters, getters, and yeah, there's no much to explain here, but it's very important to use it very consequently everywhere. And that's a topic by itself. It's a topic that I could talk about 2 hours. We are very serious about state machines. So we say, from a business point of view, I think it is a really good idea to execute your orders instead of the shop system. I think it's a really bad practice to think that the shop system is just a big checkout, and then the order is processed in an ERP system. That's a very heavy productivity killer, because then 2 teams have to work together. And we say, okay, you should process your orders in the shop system. And you do it until you ship the order, and then the warehouse management system comes into the place. And to do this, we have state machines. The state machine here is, this is how it's implemented in XML. It's very easy to do. There's no graphical user interface here, because these are business processes, not one that somebody is changing something in the back end here. So we want to go through the versioning and deployment. This is a graphics representation of this thing here. It's a little bit easier to talk about with business guys. And then the state machine here is executed. So PHP, when the event comes, here authorize, the PHP will path the XML, will create an object, tree in memory, and then there are commands and conditions. Like this here, authorize. Behind this, there's a PHP class, which will be executed inside of the transition. So as I told you, I could talk a lot of it, but it's extremely powerful. And this is basically what all Rocket Internet shops after Zalando and Project A Ventures shops use, basically, to avoid ERP systems, because it's so much easier to change something here in XML than to call the ERP team and say, hey, we want to call the customer before you ship. So here, that is one line. Takes 5 minutes, and it's really a huge benefit. It takes a little bit to come into this way of thinking, of programming by drawing, programming on a whiteboard, and then put it into XML, and that's it. That's the code. There's no spaghetti code anymore, so everything is in XML. But that makes a lot of sense. Finally, if you're interested in Spryker, you can go to this start Spryker.com. There's installation guide. We have a virtual machine, Vagrant, or VirtualBox, and it's a little bit tricky to install Spryker without this, because we have so many technologies that I really recommend. It's pre-provisioned, so it's a 900 megabyte download. That's the longest part of the installation. We could also give you salt stack stuff to build by yourself, but it will take longer. And And then the repositories are completely open. So the code is completely free. There's nothing encrypted. There's nothing that we hide. Everything is public. As I said to you, we do not publish our working repository. We publish only the subtree splits, the bundles itself. And yeah, even if you do not want to install it locally, you can still go to our GitHub repositories, 100, and have a look inside of the code, if you like to. And if you install it, what you get is this. This is our demo shop here. It is a shop fully working. You shouldn't compare to our Shopware or Magento Oxid demo shop because this is a framework. The idea is to not have so many features. That's why the demo shop is a very small set of the features because it's a framework basically. There's no much sense to build one specific demo shop, which then again doesn't fit to what our customers want. There are some more links here. We have a documentation, so the Spryker is documented. Our architecture is documented, and most of the features are documented. We have a forum where you can discuss with us. All the core developers are there. You can talk with them. We have a tech blog. It's only one entry. It's just 1 week old, but feel free to put it to your RSS reader. And yes, and if you want to look at Scrutinizer, the Scrutinizer rating is also public. You can also see what's not good in Spryker, so if you like to. Thank you very much. And feel free to ask questions now, please. Nobody's asking questions. You. Yeah, we have a we have an admin interface. It's not very. It looks really good. It's based on an Inspinia theme, and it's very powerful thing to build your own forms and grids. But the question was, do we have an administrator UI? And the answer is yes, we have. But it's not something we would like to show here because it's of course we have it. Yeah.
Be how to extend the admin interface. Say I introduce some new kind of model or database table or something in my application, say for my warehouses or concert tickets or whatever, and I need a simple CRUD interface in the admin GUI. Would I have to build that myself? Do you provide some tools? Is there some sort of generation framework?
No, we have currently we do not have a scaffolding tool, so it's not that easy. You can use Symfony forms. We're completely Symfony compliant, and we also have a tool to build tables with pagination filters. That works out of the box. We are thinking right now to make it a little bit faster to do this, but currently most of the pages that we have in the administrator backend are very, very, very customized. So most of the time you want to have something fancy and not something fast. So, but we have this. Yeah, it's there. But anyway, I think it's one of the must-have features. And the more interesting question is how can you hook in? Well, the best idea would be to build a new bundle and then to hook into the navigation. It's also XML file. We're using Twig for templating engine. So you can just build your Twig templates using the front-end infrastructure that we have. This is a completely different topic. A topic that I'm not the. If you want to know about front-end, you can talk to Alessandro there. So I'm not the big expert here. We're using Webpack, NPM, and so on. But there's everywhere you can see hooks. Everywhere you can hook into the system.
All right, thanks. One more question while I'm at it. What about data import and export? Do you come with some sort of, I don't know, CSV, XML format, import functionality out of the box, something like that?
Well, it's a question of the approach. Our database structure is normalized. It's very, very simplified. And I do not think that we need this tool because, I mean, to read a CSV file and put it into a very simple database structure, that's something that developer can do. So the opposite of having very, very strange database structure and then to offer some tool to put data into it, but this is not what we want. We decided to go a very, very simple way. For example, our attributes, the product attributes, this is always one of the challenges in every shop system. We're using a document database. So in Postgres, you can put the attributes in one field, in JSON, and then you can use JSON to query these fields. So, but an import is very simple. You just put the attributes in one field. That's it. So.
All right, thanks.
No question? Okay. Then time is over. Thank you very much.